In this video, I'm going to look at graphing a cosine function. So we're going to look at y equals 3 cosine of 2x plus 1. All right. And I always start out by identifying the key features of the graph. The amplitude is going to be 3. The midline is going to be, if you look there, we've got a 1 added, so it's been shifted up 1. Midline is going to be y equals 1. There is no phase shift, so you can say it's 0 or it's not applicable or something like that, or just draw a line. The period, okay? The cosine function has a period like the sine function of either 2 pi or 360 degrees, depending on which you're using. Remember, you always divide by that multiplier out in front of your variable, okay? So this graph is moving 2 times as quickly, means the period's going to be half as big. So you can divide, if you're working in degrees, the period would be 180 degrees. If you're working in radians, it would be pi radians. And anyway, we can go from there. Now, when I'm doing these graphs, I normally will focus on the intersection points along the axis of the original function. The cosine function intersects the axis at negative 90 degrees, or negative pi over 2, pi over 2, or 90 degrees, and then 270 degrees, which is 1.5 pi, or 3 pi over 2 is usually how we write it. And so remember that you can take that and you can basically compress that down just by dividing. So you've got negative pi over 2, and 3 pi over 2, okay? Each of these is going to be divided by 2 because the period's supposed to be half as big. So that would give us negative pi over 4, and 3 pi over 4, or negative 45, 45, and 135 if you divided all those original values by 2. Okay, so that's where it's going to cross the axis. There is no phase shift, so we don't have to add or subtract anything here. So at this point, we can get going. I'm going to draw my midline at 1. I think I'm just going to use each tick mark as 1 this time. This has a pretty big period. So we're going to make this 1, 2, 3, and so on. I'll draw my midline in here. By the way, there's a lot of action. This is pretty compressed down. So I have actually made pi radians out this far. I've got 8 tick marks there to go all the way out to pi. So 1, 2, 3, 4. 4 would take me to pi over 2 in the negative direction. So because I'm dealing with fourths occasionally, I thought it would be good to have something that was divisible by 4. So that's how I set my graph up. Okay, so negative pi over 4, and 3 pi over 4. That's 1/4 pi. So anyway, I've got this going out to 1/2 pi. So 1/4 pi, that would be negative pi over 4. That's going to be right here. That's one intersection point along the midline. And then pi over 4, the way I'm doing this, every 1/4 is 2 tick marks. So that would be pi over 4. And it's going to intersect the graph there. And then this is 1/4, 2/4, 3/4 pi would be right here, 3 pi over 4. Okay, so those are my intersection points. Go back and look at the original function. The amplitude of this is 3, which is why I'm only counting by 1 on my y-axis this time. So we can go halfway in between these points here. We go up first, 1, 2, 3. It'll max out at a value of 4. Okay, go halfway between these points here and go down 3, 1, 2, 3. It'll hit a minimum value at negative 2. And so the function is going to kind of loop through these points like that. And anyway, you want to kind of continue the graph in both directions. It's really a good idea if you continue plotting some intersection points out here, going a little bit farther, and that way you can draw more than one full cycle. For the purpose of the video, I'm not going to do that. But anyway, graph looks something kind of like this. Again, that point really should be more like right there. Anyway, it would be nice if you could label these other points. This is halfway between pi over 4 and 3 pi over 4. Which different ways you can count. You can count in fourths. This is 1/4 pi. That's going to be 2/4 pi, which is pi over 2. and then actually we already have that point out here. So if you can get those maximum and minimum points labeled as well, that's really a good idea. And then obviously that's at 0. I'm not sure I really need to label that. But anyway, that ends up being the graph of 3 cosine of 2x plus 1.